Hi guys, good morning. I mean, say it's good evening. Okay, you're there. Siddharth, history with okay. We'll wait for a few more minutes. Still on to okay. Maybe we'll start. Let your friends join. 1 second, guys. Okay, all right. So let me give you a problem. Can you predict the major product? So this is the reaction. So can you tell me what is the kind of reaction we're talking about here? Hmm? What is the kind of reaction are we talking about?
Intramolecular aldol condensation.
Yeah, absolutely. Right. So we are speaking about intramolecular aldol condensation products, right? So I told you how and all you need to decide, right? So yeah, anyways, get the product. I'll tell you the answer. So can you tell me what and all you have to keep in mind whenever you go for intramolecular aldol? Hmm?
We have to make sure that the base is not so substituted to prevent steric entry.
Okay, that is generally for an aldol condensation. Is what specifically what you have to remember for intramolecular aldol? For example, if I ask you, okay, fine, I don't want to give you any clue. There are just 2 points you have to remember. Anything or anything you remember?
We have to consider the less substituted carbon, which has the alpha hydrogen.
Okay, that makes sense. Fine, we have to make sure that we have to get the H plus from the less substituted carbon. Okay, that makes sense. Any other point?
We need to form a 6-membered.
Yes, correct. Most preferable one is a 6-membered ring. Right. Okay, that is 1 point. Good. Next. Okay, the clue would be aldehydes and ketones. That's the clue. So, which is a better nucleophile acceptor? Is the question. Aldehyde or ketone?
Aldehyde.
Right. Aldehyde will be a better nucleophile acceptor. Right. So now, if you keep those things in mind, right, you will be able to get the answer here. Now, sketch the product. I'll give you a minute. Go for it. Right. So by this time, you should have gotten the product. Okay. So first, if I put dilute NaOH, now the first constraint is whether I'll be able to form a 6-membered ring. We'll check, or I will go for the other one, that the aldehyde is going to be the better nucleophile acceptor. So obviously, this carbon and carbon, I'm going to accept the nucleophile, whatever the nucleophile I'm going to produce it. Right now, given that this is going to accept, right? So obviously the alpha hydrogen of this ketone is the one is going to get produced. In the sense, the alpha hydrogen of this ketone is what is going to get removed, right? So now again you have two possibilities. Either say this is an alpha carbon, this is also an alpha carbon, right? Now where to take it from, that will be decided on what membered ring you are going to form, right? So now if this attacks this, I'll form 1, 2, 3, 4, 5, 5-membered ring, right? And if this attacks 1, 2, 3, 4, 5, 6, 7, 7-membered ring. Please understand, guys, 5-membered ring is little stable than a 7-membered ring. Obviously 6 is more stable, right? But 5-membered ring is more stable than a 7-membered ring, right? So obviously what you have to do is remove the alpha hydrogen from this and make the carbanion attack this aldehydes, this carbon. Okay, right. So now we'll do that. So if I, okay, obviously after removing the H plus, I'll form a carbanion here, right? Now this carbanion comes and attacks this carbonyl carbon. And this bond breaks, right? Now I'll just first draw the 5-membered ring, then we'll put the whatever it is. Okay, so let me draw a 5-membered ring. Done. Okay. Now what I see is that there is going to be one OH. Is it not? This is going to form O minus and say there is one OH. Okay, that we have put somewhere, right? Okay. Now what I understand is, okay, now the carbon atom to which the OH is attached, the next carbon atom and the next after that is having a C double bond O. Again, I repeat, carbon containing OH, the next carbon atom and the next carbon atom, there is 2 carbon atoms away from the carbon atom having the OH, is having a C double bond O. So carbon having OH, the next carbon after that is having a, oh wait, that is actually a branch. I'm sorry, this is outside the ring, isn't it? Right. So what I can say is the carbon having the OH, right? The next carbon is having this group. Is it not? Carbon having OH is attached to a carbon atom which is having this particular group. So carbon containing OH, the next carbon atom is actually having a COCH3. So this is going to be a COCH3. Right. Okay. Next one, if I move to this side, that is the OH is this side. So the carbon atom having OH, the next carbon atom is having a methyl group, right? So carbon containing OH, that side is done. So this side, you have to put a methyl group. Right. Now this is the aldol product, but in the question they have asked me aldol condensation products. So obviously I have to remove H2O, right? So remember, you are going to form alpha, beta, unsaturated aldehydes or ketones. That's what is the product, right? So obviously, this is alpha position, this is beta position. Am I right? No. I have to form, this is my alpha position. I have to remove the hydrogen. Am I doing it correctly? OH, H. Oh yeah, no. This is alpha beta hydroxy alcohol. So yeah, I have to make the double bond here only. There is no sides of rule here. Please understand, right? Here it is not about sides of rule. You must always form alpha beta unsaturated aldehyde or ketone. So now if I remove OH and the H from this, you will be ending up with methyl group here, right? Anybody got this answer or this answer? No, nobody got. Okay, right? But at least everybody understood how this product came. Like if at all I followed sides of rule, I removed H from this and OH from this and H from this. I would have found a double bond here, right? But that I should not do because I should form alpha beta unsaturated aldehyde or ketone. That is why we're ending up with this product. Okay, is everybody understood how I got the product?
Sir, I didn't understand the sides of rule thing.
So if I followed sides of rule, right? If this is a sides of product, I would have got this one, is it not? Because this is more substituted. Correct. Sides of soul says that the double bond should be found within carbon atoms which are more substituted. So definitely this would have been the sides of product, right? But look at this. This is actually not a sides of product. But why am I doing this? Is because I need to form only alpha beta unsaturated aldehyde or ketone as the alveolar concentration product. That is what is the mechanism says. I cannot go by this. That's why I am not forming this, but I'm forming this. Yes,
So, but
understood.
both sides
Yeah.
are substituted, right?
Yeah, both sides are substituted. But see, this is the carbonyl carbon. For this carbonyl carbon, this is my alpha position, that is the beta position. So alpha position, beta position should only have the unsaturation. What I'm telling. Yes.
Yes, I understood that. Alpha beta product should be formed
Yes. Yes.
unsaturated, but then that say like both of them are substituted, but
Yes, both of them are
then
substituted. Correct. Both of them are substituted. But this you cannot take it as substitution because this is not a CH3 or just a carbon. This is a carbonyl carbon. Yes, broad sense, yes, they are both are substituted. But even if say something, I had a bulkier group, say I had a, instead of this, if I had a phenyl group, this is more substituted then, right? Then also I will form the double bond here only. That's what I'm telling. Yes, understood?
Yes. Yeah.
Okay. Right. So just one thing, alpha beta unsaturated product is what is required, nothing else. That's it. Okay. Maybe if you do one more problem, maybe you will be able to get the hang of it. Right. So please, if you're taking this down, I can rub this. I mean, if you join 4 of you. Cool. Right. Okay. Today you had school, guys.
Yes.
Today you had school. Great. Today also exam. Don't tell me. Is it? You had any
Not
exams
for
today?
us, sir.
Okay, for maybe for some other department, not department, some other groups. Okay, right, fine. Let us look at this problem. Okay, so I go for ozonolysis, CH3 twice S. Then I go for KOH in the presence of C2H5OH and heating. And at last, I go for N2H4 in the presence of OH minus. Okay, right here in the presence of OH minus as well as heat. Find the final product. Do it slowly. Okay, at least. Okay, first is ozonolysis. We know. The second reaction is
Elimination.
okay, right. So what you have to understand is, guys, elimination is definitely a thing. Definitely, you will think that alcoholic KOH is there, right? But there are certain cases where this can act as a base also. I think we have seen that. Is it not? Or elimination also you take. How is it undergoing elimination? For example, if I have say something like CH3, CH2, Cl, right? If I put say RO minus RONA in the presence of ROH, I know I'm going to get CH2 double bond CH2. What is the role of this here? What is the role of this particular species on this? What is it going to do? What is it going to do? Yes, someone is trying to say something. It's okay if you're wrong. I don't mind. What role does it play? It is going to act as a, if it is going to act as a nucleophile, what will happen? Cl minus will be replaced by RO minus, right? But if I want elimination to happen, what role does it play? Okay, it is going to act as a base, right? What will happen? Say now I'll say first step would be formation of this carbocation, and what is going to happen? This is going to act as a base, so I'm going to remove the H plus to form CH2 double bond CH2, right? So please, or you remember it like this. I know alcohols are weak bases, sorry, weak acids. They're little acidic, right? So I know the conjugate base will be a strong base. Is it not? I told you, weak acids, strong conjugate base, and vice versa. Isn't it? So my ROH is a weak acid. So the base, the conjugate base, after removing H plus, will be a strong base capable of removing the H plus. Right? So that is the role which is going to be played here also. Right? KOH in the presence of this thing will basically form C2H5O minus K plus. Right? So that is going to act as a base. Right? So obviously now you know what kind of reaction is going to happen here.
Nucleophilic substitution.
If it is going to act as a base, how nucleophilic substitution? Okay, first tell me, I have an alkene. It is going to undergo ozonolysis.
Sir,
What type of?
dehydration.
Wait. First, I have an alkene. I go for ozonolysis. What will be the first product? What kind of products will be formed?
Carbonyl compound.
Okay, carbonyl compounds. Carbonyl compounds with a base. I'm telling you that it's going to act as a base. Then what is the reaction?
Aldol.
That's it, aldol. What is this reaction? N2H4 in the presence of OH minus in heating. What is this reaction?
Wolff Kissner.
That's it. Go for it. Tell me the answer. Now, obviously, since it's a cyclic compound, you know that you're not going to form two different carbonyl compounds. I'm going to form two different carbonyl groups in the same compound. So obviously, the aldol condensation here would be an intramolecular aldol condensation. Right? Now, go for it. So here you don't have to worry about whether it's a 6-membered ring or a 7-membered ring or whatever it is, because it's going to be a symmetrical compound. The carbonyl compound, the dicarbonyl compound is going to get formed is going to be a symmetrical compound. So you don't have to worry. You can just take any alpha hydrogen and attack the other carbonyl compound. Okay, I hope you're done. Right. So ozonolysis, I know what is going to happen. I'll just remove the C double bond C, put a C double bond over here, and a C double bond over here. This is very simple. Right. Okay. Now I'm going for aldol condensation. So in aldol condensation, now it's a symmetrical compound. You don't have to worry where I'm going to take the hydrogen from or where it is going to attack. Right. Say if I remove the H plus from this, I will form a carbanion here, and that is going to attack here, and this bond will break. Right. Okay. Now let me see how many member, or let me draw it properly. So this, okay. Now I have a C double bond O. This and this are joined. No issues, right? Okay, done. So, oh, I have a OH. Yes. Right. Now this is my aldol product. If I have to go for aldol condensation product, right? So again, I have to go for alpha beta unsaturated. Please understand, this is the carbonyl carbon. This is my alpha carbon, and obviously, yeah, I have to remove the OH from this. So alpha beta, first carbon, second carbon. So now if I write it properly, see how many membered ring is there? 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7. 7 membered ring, right? So let me draw a 7 membered ring. Very bad at drawing. Okay, a 7 membered ring, right? So a 7 membered ring with 1, 2, 3, 4, 5, a 5 membered ring, and it has 2 joining points. Okay, 7 membered ring with a 5 membered ring, and you see, wherever is the joining happening, wherever there is a fusion between the rings, the next carbon is having a C double bond O. So wherever the fusion is happening, say the next carbon is having a C double bond. Okay, and what you see is I have to remove this alpha, this hydrogen from here and the OH from here. So definitely there is a double bond. Right? So you can see alpha, beta, unsaturated, aldehyde or ketone. Right? Okay. Now what is the last one? Last one is my Wolff-Kishner reduction. So now what is going to happen? This C double bond O is going to get removed, and I'm going to add 2 hydrogens to this. Right? So the last product, if I go for Wolff-Kishner, again a 7 membered ring. Okay, a 7 membered ring with a 5 membered ring, right? And with a double bond here, this would have been the final product. Okay, anybody got the answer?
Yes, sir.
Good. Okay, fine. So it's pretty easy. All the reactions, you know, you just have to do it very little slowly so that you'll be able to get the answers. That's it. Okay, right. Fine. Next question. And guys, I want to tell you one more thing. It is not only aldehydes and ketones that are capable of giving your aldol condensation, right? Okay, aldol condensation will give only aldehydes. Now the thing is, the similar type of reactions are possible with other functional groups also, right? So if you remember when we talked about tautomerism, right? I told you the alpha hydrogens of aldehydes and ketones are acidic, right? But I also told you that there are other functional groups, right? For those functional groups also, the alpha hydrogen is acidic. Can you tell at least one of them? For any other species other than aldehydes and ketones, their alpha hydrogen is acidic.
Terminal alkynes.
Terminal alkynes, there it is not alpha hydrogen; it is their own the carbon having the sp hybridized carbon. That hydrogen itself will come out. That is not alpha hydrogen. Yes, it is acidic.
Amines?
No. Okay, so let me remind you, maybe you forgot. Oh, I'm sorry. Are you taking this down, guys? I'm sorry. Okay, so the other two are nitro group and cyanides. Both these things are capable of undergoing an aldol. I cannot exactly same mechanism. Mechanism is going to be exactly same, but I cannot call it as aldol because it's not an aldehyde or ketone, but some condensation product. Okay, right. For example, if I had say CH3, CH2, NO2, or say CH3, CH2, CN, right? Now this hydrogen is capable of coming out. Now let me prove it to you, right? So if I remove this hydrogen and put a negative charge, if this conjugate base is stable, then I can say that this is okay, right? This can come out as H plus. Now don't you see that it is resonance stabilized? Same goes with your Cn. If I had CH3, CH minus, obviously after removing H plus, if I have C triple bond Cn, this will come, this will break, right? Exactly what you see in case of your aldehydes or ketones, right? So if I have to make a reaction, I can make it happen here. Say if I had CH3, CH2, NO2, right? Now say if I put a base, any base as you've seen before, I will form CH3, CH minus, NO2, right? Now I have to take another molecule, right? Now what will happen? This will come and attack here. This bond will break, right? So what will form? Say if I start here, I'll be forming CH3, CH2, NOH. This will become O minus, taking the H plus, and I have this. And what is there? Here I have a CH with the CH3 with an NO2, right? This would have been the product. Okay, but this doesn't undergo any like this doesn't undergo any elimination for water molecule. No, that doesn't happen. This will be the final product. Okay, this will be the final product. Okay, I see. Did you see any difference with respect to aldehydes or ketones? The only difference you would have seen in this that instead of carbon, I have a nitrogen here, an extra oxygen atom. Rest all are going to be exactly same. Okay, please remember this. Okay, so other than aldehydes and ketones, even there, even the NO2 groups and the cyanide groups also have their alpha hydrogen to be acidic. So they can also undergo condensation reactions like this. Okay, right. Fine. Moving on. Okay. So if I have C6H5, C double bond O, CHO. Okay, right? Now they are giving, I have concentrated NaOH, and after that I go for hydrolysis. What is the final product? Okay, now tell me, what reaction is this? What reaction is this? Aldol condensation? Is this going to be aldol condensation? Okay, I'll take a vote. How many of you say that this is going to be aldol condensation? Again, it's only a guess game. Go for it. Okay, nobody. So all of you are telling that this is not going to be aldol. Can I take it like that?
Yes, sir, it looks like aldol condensation, but there's a ketone.
So what is the only requirement for a aldehyde or ketone to undergo aldol condensation?
Alpha hydrogen.
That's it. Right. If I have alpha hydrogen, well and good. Does it have any alpha hydrogen?
No, sir.
Yeah, this doesn't have any alpha hydrogen. C6H5, like you can see, if I write the structure, C double bond O with a CHO. Right, now there is no alpha hydrogen here, and please understand, this hydrogen cannot come out. Like, see, you should have a hydrogen atom, alpha hydrogen possessed by an sp3 hybridized carbon, but you see here, or say if I had hydrogen here also, for example, then also it will come, because both these carbon atoms are sp2 hybridized, not sp3 hybridized. Okay, right. So, okay, fine. It doesn't have alpha hydrogen. So, what kind of reaction is this?
Canizaro.
Canizaro, right? Same not mechanism, same reagent only. I'm going to use base. That's what I'm going to do, right? But the role it plays will be a little different here. But fine. Now, here you see, I know what is Canizaro. It is an disproportionation reaction, right? So, one thing will get oxidized, same thing will get reduced. Okay. Right. Now, this is an example for intramolecular Canizaro reaction. Right, intramolecular Canizaro reaction. Right. So you should not take two moles of this compound. Say one of the carbonyl compounds will get oxidized, the other carbonyl compound will get reduced. It is as simple as that. Okay. Right. Now, how will we decide? For example, we will come back to this problem later. Right. Say if I had have taken HCHO plus what should I say? If I have to take anything, say I had CH3. No, this will not work. Right, I go for OH. Right. So this is an example for your cross aldol, not aldol, cross Canizaro reaction. Okay. So if you can understand this, you can understand that very simply. Okay. So this is a cross Canizaro reaction. Now, generally in Canizaro, what happens? Only one will get oxidized, the other one will get, the other thing will get reduced. Right. Okay. Now tell me, which will form, oh, what do you think? You might or might not be right. So out of these two, which will form acid, which will form the alcohol? What do you think?
Sir, aldehyde is capable of producing an acid.
Yes, that's it, right? Right. Obviously, you know you cannot oxidize ketones. Impossible. Right. That is one thing for sure. And if you remember the mechanism, what is going to happen? If you took benzaldehyde, basically from this C double bond O H, and I'll have another C double bond O H, I will just remove this hydride H minus, and that is going to attack this. Then only the reduction will happen, isn't it? So now you understand, obviously the hydrogen attached to the carbon and carbon is coming out. Right? Now, does ketone have any of those features? No. Right? So definitely ketone will accept the hydride to form your alcohol always. Please remember this. In a cross Canizaro reaction or an intramolecular Canizaro reaction, if you have an aldehyde, that aldehyde will always form the acid and ketone will always form the alcohol. Keep this in mind. Okay, aldehyde will form the acid and ketone will form the alcohol. Right, now I think this will be easy problem for you. Go for it. So here the product would have been, in this case, I have to tell you, in this case, I'm telling not this case. So I would have formed HCOOH plus PHCHOH pH. This would have been the product. Ketone getting reduced, aldehyde getting oxidized. Okay, Now I think you should have gotten the product by this time. So if I sketch it, it will be C6H5 CHOH COH. This is okay. And anybody get this answer?
Yes, sir.
Good. That's it. So this is my ketone, which will get reduced to form alcohol. CHO will become COH. That's it. Right? Okay. Again, an easy question. Not easy question. You have learned something new, right? Okay. Okay. This is going to be an interesting question. Okay. I have marked this carbon. Okay, DaCO3. The carbon is marked, and I'm making a react with HCl, and there is a gas X which is getting produced, and that is reacting with CH3, CH2, CH2, MgBr, and I go for hydrolysis after that. What is the product? Okay. This involves a bit of inorganic chemistry as well, but again, not so much level. This is your, I don't know, 9th or 10th level chemistry. Okay, can you tell me what is this gas? What gas is this? X. Okay, we'll go back to 10th class. Metal carbonates reacting with bases. What are the products? For example, if I have say Na2CO3 reacting with HCl, what and all will be the
Salt.
products? Salt.
Salt, carbon dioxide, and
Okay, salt, carbon dioxide, and water. Right. So, what is the only gas present here?
Barium chloride.
carbon dioxide.
Asking only gas is carbon dioxide, obviously. The salt and H2O will form the aqueous solution. Right, the salt and this H2O will mix together to form the aqueous solution. And the only gas I have here is basically going to be CO2. So now this gas is basically going to be carbon dioxide. Okay, now what you see is carbon dioxide reacting with Grignard reagent. Oh my God, you don't have to worry. It's the same thing what you have studied. Just go by the mechanism. Right? You know how carbonyl carbon reacts with Grignard reagent. That is also carbonyl carbon. Right? Now go for it and tell me the answer. How much time we took? Oh, we're exceeding the time. Okay, but still. Okay, so maybe we are doing too much organic, right? I will finish this up, right? Maybe we'll go for some physical, right? And then maybe we'll come back to amines later. Okay.
Sir, is it C double bond O OH CH2 CH2 CH2?
Yeah, CH2, CH2, CH3. Yes, that's the answer. Okay, pretty easy. Now, guys, even though I didn't teach you this, this is, I think you must be, now that you have learned so much organic, you must be good with mechanisms, right? Now, let me tell you the mechanism of this overall. Say, if I had RMGX, and if I'm going to make this react with CO2, right? Now, I know the R minus will come from this. R minus attacks the carbonyl carbon, and this bond breaks, and the MgX plus attacks this oxygen. So what will you have is, I will say R is attached to the C double bond O, and that is having OMgX, and obviously after hydrolysis, I'm going to form RCOH. That's what is going to happen. This is also a method of preparation of acids, a very good method of preparation of acids. Right? Carbon dioxide is easily available, and Grignard reagent is also one of the cheap reagents available markets, right? So you can easily form the acid here, right? Same thing is gonna what is happening here. Instead of this R, I'm going to have this particular group. Okay, right? So now if I do this, basically this X would be CO2 mark this carbon, because this is the carbon that is going to come out. So I have to mark this carbon, right? And I'm going for, okay, I'll write it like this. C double bond O with an asterisk mark. I have CH3, CH2, CH2 minus MgBr plus attacking here, and directly going for hydrolysis will form CH3, CH2, CH2, COOH, and this is the carbon which is still marked. That's it. That is the answer to this question. Okay, right? Okay, I think this reaction should be there in NCRT also. Is it? It's there, right? CO2 with Grignard reagents.
Yes, sir.
You have definitely, right? Okay. Next question. If you have taken this down, okay. I'll rub this. Next question is this. This is the first reagent. Second reagent is H2CrO4, and after that I go for this CH2 double bond PPH2 3. Okay, and heating. What is the final point? Okay, fine. My responsibility, I should ask you, what is the first reaction? What is the first reagent? What is it going to do?
Hydroboration oxidation.
Okay, hydroboration oxidation. What is the role of this H2CrO4? Okay, maybe you don't know. If you want to take a wild guess, what that would be, the role of this. Come on, guys, you should be good at guessing.
Oxidation.
That's it. Right. This is how do you form this is very simple. If I put CrO3 in the presence of H2SO4, and this is what is my chromic acid. Right, chromic acid, like if you just put this is what is my Jones reagent. I can either represent it like this, or I can represent it like this, right? So this is going to be an oxidizing agent. Okay, fine. Now this, if you answer, I will really appreciate your remembering skills. What is this reaction?
Sir, instead of that carbonyl carbon, is
instead of carbonyl carbon?
No, instead of the carbonyl carbons, oxygen. The group will replace.
Okay, fine, correct. You're right. Okay, what is the name of the reaction? It's a name reaction, right? Hmm? Name of the reaction?
Wittig reaction.
Absolutely, very good. This I appreciate. Okay, so yeah, this is Wittig reaction. WITTIG, addition of ylides. Right? Okay, go for it. Now that you know every reaction, I think you'll be able to solve this very easily. Go for it. Still only 4 of you are there, or some more people joined. Only 4 of you. Great. Guys, I understand that some of you are tired, but if I tell you my schedule, maybe you'll feel better. Okay, fine. So today being a Saturday, generally my college is off. Like we don't have any classes. But today, the faculties are so what to say, so genuine that he was into some research and he forgot about a class. He didn't take it. So he compensated it today, Saturday morning, 9 o'clock. Right. Okay, that is one thing. And today was the last submission for me for submitting an assignment in thermodynamics. Okay, let me tell you about the subjects later. Okay, so it had around some 15 questions, and it is not some normal questions, people. It is I had to if you have seen me, I just sat with around like some 5 books around me like a math person, and I was searching from all the books, to get the answer, and I mean, eventually I have to use some net also. So that I did. And there is something called as lab rotations. Lab rotations, obviously, you'll ask me how you have labs. We also have labs, but it's not like the normal labs. We really have to do something there, right? So again, it's now, since it is what is that, online. I don't have access to the labs, but still I have some reading assignments. Have you ever heard of assignment? It's called reading assignment. Yes, we do have. So in that reading assignment, there'll be research papers given to me regarding whatever the supervisor gives me. And this is not today. I have been doing it for the past almost 10 days, right? So that I had to prepare, first read it, and have to prepare a PPT. And I also should say, how can I make these whatever I'm studying about better? I mean, in the lab, in the practical point of view. I have to think about it. And then now I have your class, right? And after this, I have to go meet my friends. Maybe you'll think that that is actually a jolly time. It is a jolly time, but still, I have to go from Mailapur, and I think I have to go to, what is that place? Okay, it's near Krompet. Fine. So this is my schedule, right? And you know why I don't take class on Tuesdays? Because Tuesdays I alone have 6 hours of classes. Okay, and the last class gets over by 6:30 in the evening, right? But what I do, I didn't take your class, but I take 11th class in the morning, 7 o'clock. So I wake up at 7 o'clock. So that is 1 hour, right? And 6 hours of that, right? And if I really have to take your class, I will take it. But you will easily see it in my face. Sometimes you would have seen me, my eyes would have been so blackish and stuff and all that. So this is my schedule. Okay, so I really hope this. Why I told this is because everybody has their own things going on. Like, it is not only you who are doing multiple stuffs. Okay, there are so many people. Maybe my schedule is very less because I don't just sit with the books for so much time to study. But if at all people do that, that will again take up a lot of time, right? And so that is one thing. And if I have to tell you about my subjects, right? So for you in chemistry, chemical kinetics is one chapter, electrochemistry is one chapter, and say organic, like an alkyl halides or whatever, all these solid state is another chapter. For me, all these are individual subjects. Chemical kinetics is one subject for me, 4 credit subject. Thermodynamics is one subject. Kinetics is one subject. Organic, I don't have to tell you. I believe about it. This is another level, that is. So yeah, so for your level, if you have your own problems, for my level, I have my own problems. For your parents' level, they'll have their own things going on, right? But irrespective of that, right, we are obligated to do something for ourselves. It's not that you're doing something for anybody else, right? We are obligated. We have been given a responsibility, right? So I can easily tell it'll take only 2 minutes for me to tell, put it in the group, guys, I'm tired, I'm not taking the class, right? But I would prefer not to do that, because it is not only me. I have a responsibility of taking care of you in terms of teaching you, isn't it? So if one thing you remember in life, do not shy away from your responsibilities, no matter what. You try your level best, and if you're not able to do it, then it's fine. But without trying, this feeling that I have something so much to do, that is really not going to help you, right? See, at least our lives being students, you and me, don't think like I'm putting it in your age. Like, just think, saying that both of us being students, right? At least you don't have multiple things to do. You don't wash your clothes, you don't cook your these things. Only thing you do is go to classes, go to school, come back, study, maybe attend classes here. You are doing everything related to something which you're already doing for a so long time, right? But think about a mom. Think about, I don't know how many of your moms are working, right? Think about their lives, right? They have the morning wake up, cook, clean everything, wake you up, say pack your lunches if at all it's a normal, not non-COVID time. Go to office, work there, come back again, do the same thing. So hope you understand, our lives are actually much better than so many others. Okay, so I would really appreciate if you stop complaining and whining about it, right? And if at all I talk to my friends, I'll talk in a different way, but still, you really have to gather some, no words, gather some courage. Okay, right? So yeah, right. So even I do feel bad, like maybe you are feeling it now because maybe it's new to you, so much pressure. But I'm telling you, this is how life is gonna be. Maybe if you go to college, maybe you can chill, right? Maybe that's only for 4 years. Again, you can chill only for those 4 years, right? But again, after that, once you go to work, man, I'm telling you, life is really not going to be the same, right? So you will have that too. If you're going to work in a corporate company, done, right? So they will have their own targets, and they are paying you money. Obviously, you cannot say no, that I cannot do this work. Just like how you tell your parents, or indirectly tell your teachers that no, I'm not going to do your homework, I'm not going to do your assignment. Or you tell your mother that, hey, please take this. No, you will tell, no, why should I take? And you'll sit in the hall and call, mom, water. Please change all these things. I don't know whether you're doing all this, but I know in my childhood, I did some of these, right? But it took a lot of time for me to realize that you are not the only person who's suffering. There are a lot of people, and please thank any upper force. I don't believe in God, whatever you believe in, please thank the upper force that your life is much better. Be thankful for it and really appreciate it, and try to get yourself life better, not by shying away from responsibilities, but by doing what is required and what is given to you as a responsibility. Okay, right? Maybe one more story and we'll concentrate on the problem, right? um, okay, so I told you that in college you'll be able to chill, right? But my life was a little different, right? I was chilling actually, like 4 years I chilled, right? I really don't want to tell you what or not I did, because maybe you will not see me as a teacher anymore if I tell you all that. But anyways, so the thing is, when I was in my second semester, right, my father died, right? So we were not that well off as a family. We were doing okay, right? But my father expiring was actually a huge burden, a huge financial burden. Even though my mom was a teacher, she was a government school employee and all that, but still, that impact, whatever impact was there, right? So till then, I was really a very rusty kid, I should say, right? But after the things changed, right? What changed is I decided that I am not going to ask money from my mom. I was just my first year. I was like starting my second year of college. So what I decided is I will earn somehow. So I started searching for jobs, part-time jobs, and I thought what I'm good at. I thought I'm good at I thought I'm good at chemistry. So there was this institute time in Tanjavur. So I went, I applied, I got through, and that is not it. After that only the struggle starts, right? So obviously after college, my college gets over around 4:30, 4:45, and I have to run. I have to go for around 12 kilometers from my college to the Tanjavur town to teach them, and all my friends would be chilling again. Okay, that is not it. Saturdays and Sundays are mandatorily parties. Okay, hardcore parties. Again, I don't want to tell you what we do on the parties. Okay, so anyways, so hardcore parties, right? I cannot say no to my friends because that is really not a good behavior. So I will indulge, right? But they don't have any other, say, Friday night or Saturday nights, right? Like next day they don't have anything to do. But especially on Sunday nights, I have to wake up by 5 o'clock. And from Tanjavur, I need to go to another district. I'll be seeing all my friends sleeping. I'll be seeing all my friends are sleeping, and I have to wake up, right, and go teach the class. Whatever. That is not a normal class. That was like 8 hours of me teaching, right? Okay, obviously students will change, right? So that is 8 hours of me teaching, right? And if you ask me how much was the money, money was not so much, right? They were paying me around some 300 to 400 rupees per hour, right? So yes, I was able to take care of my own expenses, right? So why am I telling you all this is again repeating the point. Now I'm very sophisticated actually. Now I'm very sophisticated. Like I do my things, I do my things at my own time, all that. But the thing is, unless I could have easily shied away. I could have easily if I have told my mom, see, I really cannot do this. I really want your support. My mom would have blindly told me, yes, you don't have to do anything. You know moms, right? You know how will they behave, right? But there are certain times that you come above that, you come above your comfort zones, right? And really say it is a bad thing to say, but my father dying for me was a huge turning point, right? Maybe I was good at studies, but I was good at nothing else, right? But yeah, that was the turning point. So what I'm trying to tell you, what is the moral of the story here is, you don't have to wait some miracle to happen in your life for you to change, right? So you can just learn from people's experiences, right? And then actually you will be able to say, learn that and apply it in your own lives, and actually that will make your lives better, right? So two things: one, do not shy away from responsibilities. Second, stop complaining. Appreciate what you have in your lives, right? So anyways, there was so much gyan, right? Okay, it's nice sometime, right? What I feel is, you guys are very like so talented guys, so talented boys and girls we have in this batch, but none of you are actually utilizing it. None of you are utilizing it, right? Maybe in the class when I ask you questions, may 90% of times the question gets answered by some of you, right? But not enough. There are still more many things you can do and with whatever the time you have, but you choose to go for some petty gains, right? For example, say go to scrolling through Instagram, or say Facebook, talking with your friends, or watching match, or whatever it is, right? Now that should be the minimal part of your time. You can tell me, sir, already that I'm doing that minimally. That should be still less. At least now that you're in your prime situation, in the sense that board exams are coming, JEE is coming, that is coming, this is coming. It's high time, guys. It's high time that you really utilize what you have here. What is the point in locking it and not utilizing it, right? So it's like a boxer. It's like a boxer. Say a boxer who has been competing for a long time. As and more and more he competes, the better he gets, right? But say 3 months, ask him to take rest and then go back. He will at least lose the first 3-4 matches after that gap. So once you're gonna give a gap, you must always be at your primes, right? And irrespective of that, sometimes you'll face failures. That is unavoidable. But you not trying and expecting something to happen, life is not going to be like that. Life is not that easy, guys. Okay. Anyways, okay. So, okay, I'll give you 2 more minutes to solve this problem. Go back, go for it. Oh, 610.
Sorry, what's the second reagent used?
This one,
No, the other one, sir.
this one, CH2
Yes.
double bond PPH3.
Oh,
Yeah.
Sir, is it in place of the oxygen it's CH2 and in place of the double bond CH2 it's COOH?
Yes, correct. Right. Okay, pretty simple. So first, if I go for this hydroboration oxidation, I know it's anti-Markovnikov's alcohol, so I'll put CH2OH, right? And then I'm going for oxidation. This is a primary alcohol, so directly I will form COOH, right? And that is my Wittig reaction. So hope you understand how this works. So if I have some CH or something like CH R double bond P PH3, what you have to do, just replace these two, right? Or put P double bond O and C double bond C. That's what you need to do. And this is what is my Wittig reaction. And you will easily see that this is going to go, and I'm going to have on double bond CH2. Okay, very easy reaction. All right. Okay, so that is about this problem. We will move on to the next one. There are actually so many problems we can do, but I'm just selectively doing it because okay. So I'm gonna give you 4 choices. See, heating. Okay, so for all this, cyclohexane is my starting product. Okay, so we will see no reaction is there. The reactant in all these cases is cyclohexane. Right, now what they are telling is from cyclohexane I have to convert it into adipoyl chloride. Okay, fine. So adipoyl, first of all, what is adipic acid's formula? If you know adipic acid, this is very easy. What is adipic acid's formula? Polymers. There you have seen adipic acid, right?
So it's actually delete.
Oh, it's deleted. Okay. So guys, you need know certain acids. Okay. So you know already oxalic acid, COOH and COOH. Adipic acid is going to be like this: COOH, CH2, 4 times COOH. Okay, COOH, CH2, 4 times COOH. If I say adipoyl chloride, that's it. Remove the OH and put ClCl. COCl, CH2 4 times COCl. That is what is my adipoyl chloride. So what you have to form is C double bond O, Cl, CH2 4 times C double bond O, Cl. From this, you need to form this. And what is the best method of doing that? For that, only 4 choices are given to you. Go for it. And if at all you want to know some other acid, you have malic acid. Right. Okay, you first complete this and speak about that.
Sir, first reagent. No, sir.
Cl2 in the presence of heating.
Sir, is the answer B, sir?
B for Bombay.
Yes, sir.
Yeah, correct.
Sir, is it fine if I just did it because the rest of the options wouldn't work? I didn't
Good way to
know B would work, sir.
Yeah, good way to go. Good way to go. So this is not even a reaction. So if I put fine, anyways, like D will definitely not going to be the answer, because what will happen if I have an alkane reacting with KMnO4? Nothing will happen, right? Obviously, this is not the answer. And other things, okay, if I put Br2, I will get a bromide, and this is my aqueous KOH. Okay, now aqueous KOH will replace, say I will have OH here, assuming, right? Now if I put the oxidizing agent, now remember this is a secondary alcohol, right? Maximum it can form a ketone like this, right? So definitely this is also not going to be the answer, right? So either the answer is going to be A or B. Okay, so anyways, we'll check. Right, now that you have given the answer, maybe we can check. Right, so hope you understood, right? This is definitely not the answer. D is definitely not the answer, because alkanes on reaction with KMnO4, there is no reaction like that. right? And if you look at this, maybe you will get say 2 BRs. Sorry, maybe you'll get 2 BRs, right? And if I go for aqueous KOH, I'll be getting OH and OH here. And if I oxidize this, say both of them will become ketone. That's what will happen. Again, there is no reaction with PCl5, right? So C is also not the answer. Okay, we'll check for A. What is going to happen, right? So if I check for A, first is Cl2 bar H nu. So I assume that I'm going for dichlorination. Only then this will work. Okay, say one chlorine, another chlorine, and what happened? No, not required. No, one is enough. Okay, so one chlorine, right? Say now if I go for C2H5ON in the presence of C2H5OH, that is my elimination reaction, right? So if this eliminates, I'll say I'll form a double bond O here. Sorry, double bond C here, right? Then I go for ozonolysis. If I go for ozonolysis,
We'll form two separate compounds.
yeah, you'll form this one, right? You'll form this compound. Again, one is both of them are aldehydes. It can get oxidized, but see what you're putting there. You're putting chlorine in the presence of H2O. Nothing will happen again, right? So A is also not the answer. Hope you understood what am I doing. Cl2, I put one chlorine, then elimination for this, then ozonolysis will form this particular compound. Both of them are aldehydes, not acids, right? Okay, so obviously option B should be the correct answer. So what happened? First cyclohexane with chlorine in the presence of heat, say it gives me a chlorine, then it is undergoing elimination to form this. Then if I go for KMnO4 in the presence of H plus, very important, in the presence of OH minus, it will become a diol, right? In the presence of KMnO4, we have already done this so many times. Please remember, it is just going to be like ozonolysis. But if you form if you form aldehyde, convert them into acids. Okay, so if at all you did ozonolysis, we saw what happened. What was happening? C double bond O and C double bond O with an aldehyde was forming. But if you put KMnO4, I am going to form COOH, CH2 4 times. You can see one COOH, one COOH, 1, 2, 3, 4. 4 CH2s will be there, totally 6 COOH, right? And that SOCl2, I know, is a chlorinating agent. That is how you form your acid chlorides from your alcohol. Oh my God. So acid chlorides from acids, right? So if I put SOCl2 for this, I will get C double bond OCl, and this will also become C double bond OCl. That's it. So B is the correct answer. Okay, everybody understood how B is the correct answer and how the other things are wrong? Yes? No?
Yes, sir.
Okay, good.
Yes, sir.
Yeah, nice. Okay, so any other important thing I can teach you, or the reaction which we have not seen?
Sir,
Yeah.
so whenever alcohol becomes a catalyst, like I become confused. The second.
Oh, you're telling, okay, fine. So like you should get confused, obviously, but how can you overcome this is by looking at the next reaction. Next reaction, for example, if you just confused here, now look at the next reaction. Next reaction is ozonolysis. That will happen only if I have an alkene, right? So like, or you can now in this case C2H5O minus, if they give you, it will be really confusing. But if they give you bases like CH3 tri-CONA, something like that, definitely is elimination, because you know this cannot act as nucleophile. Understood, right? So two ways of doing it. One, by looking at what kind of base they have given you. I mean, what kind of alkoxide they have given you. If it's a very bulky alkoxide, definitely elimination. Second way of doing it is looking at the next reaction. Say if they give you, now I've given you ozonolysis. Say if I have given you a BH3 in the presence of H2O2, hydroboration oxidation, any reaction which you see will happen after formation of alkene, and if they give you that, definitely this is going to act as a this is going to give me elimination. That's how you can do it. Understood what I'm trying to say?
Yes, sir.
Okay, so like in this reaction, you can see this one or this one. Obviously, you can see both of them will react only if I have an alkane form before this. So definitely, I can understand that this is going to give me an elimination point. Fine, valid question, valid question. Okay. Okay. Next question. Right, so I have A, B is this, C is this, and D is right at the top. Okay, so these 4 acids are given to you, right? And they're asking you which among the 4 acids are, or I'll just tell you, okay, which among the following acid is the most easily decarboxylated, right? Which is the one which can be easily decarboxylated, most easily, obviously.
So indirectly, they're asking which is most acidic, right? Sir?
No. For decarboxylation reaction, you have to remember the mechanism. If you remember the
Okay.
mechanism, then you can answer the question. Okay. So in decarboxylation, what was the intermediate? Okay. Again, you forgot. So I
Oh,
will
sir,
tell
it was
you.
an enol, sir.
Enol? No. Okay. See, I
Sir,
have.
carbanion.
Yes, absolutely true. So if I have this, say if I write it as carboxylate ion, right? Now if I heat it, what is going to happen? This will come, right? And obviously this is going to go like this, because obviously this carbon cannot have more than 5 bonds, more than 4 bonds. So what you have is CO2 is formed, okay? But you see the bond pair goes along with your R. So R minus would actually be the nucleophile. Sorry, eliminated product, the intermediate is going to be R minus. And obviously this R minus, you remove the H plus, this will react with H plus to form the alkane. That is okay. That is what a decarboxylation reaction is. What you have to understand is the intermediate formed in decarboxylation reactions are carbanions, right? So now what you have to do is, after removing the COOH, you are going to form a carbanion. Check for the most stable carbanion. Out of these 2, out of these 4, whichever is going to form the most stable carbanion, that only can be easily decarboxylated. That's the thing behind this question, right? So hope you understand, right? Mechanisms, so many times, right? So many reactions, without the mechanism, you cannot answer the question. Organic chemistry is like that, right? That's why we spend so much time on knowing the mechanisms. But there are certain things we didn't see the mechanism. That means they are not going to test you that much, right? You don't have to worry about the things which we didn't see. But whatever things we have seen, definitely you should know the mechanisms. Okay, fine. So now I think I'll be able to answer the question.
Sir, is it D?
Is it?
D.
Oh, D for dog. This one. This one.
Yes.
Okay, we'll check. Right. Okay. So maybe, okay, maybe if any, that is not the correct answer. Okay, I understand why you would have said it, but still, that is not the answer. Right. Any other answers? Fine. Now let me remove the COOH from everything and make a carbanion. Okay, right. Now,
Sir,
if you look at
B, sir. Sir, B, sir.
B is this.
Yes, sir.
Fine, we'll see. Okay. Now, if you look at this, right. Now, I can say it is little stable because I have a highly electronegative oxygen atom present, right? So I would say it is okay. Not that okay, but still okay, right? Okay. Now, if you look at this, I know alkyl groups are going to be electron donating groups, right? So the amount of negative charge is actually increasing, and here it is decreasing because of the presence of the oxygen, and here it is increasing. Now this, see, there are two electron donating groups from this side and this side. So here I have a double increase in the negative charge. So this is the most unstable one here, right? Right. Okay. Now, if you look at this one special thing will happen. What will happen? Can you tell me? In this?
Resonance.
Yes, this will come and this will break, right? So this is resonance stabilized. So the answer to this question is this only. Say this is also stabilized, but not by resonance, just by inductive effect, right? I told you, when you have competition between inductive effect and resonance always wins, right? So in this case, it is resonance stabilized. This is inductively stabilized, right? So definitely this is the most stable carbanion among these four. So C will be the answer to this question. Okay. Yes, everybody understood? Okay, I suppose.
Yes, sir.
Fine, good. So I think we'll stop with this for today, right? And from next class I'll be teaching you. I'll start with, say, which chapter you want? Electrochemistry, kinetics, anything, or any other specific things you want? Solutions, solid
Coordination.
state, coordination compounds. Okay, is everybody okay with it? Coordination compounds.
Yes, sir.
Yes, sir.
Okay, fine then. So tomorrow we'll see. Tomorrow we'll see coordination. I am again. There are a few things you asked me. One thing is your IUPAC naming. Little we'll see. And second thing is isomerism. Varnas theory, don't ask me to teach you, please. I'm not going to teach you Varnas complex and all. So one thing I'll teach you is your isomerism, naming, and crystal field theory. These three things will teach you, and we'll go for solving some problems, right? So maybe I will take 1.5 classes for me to complete that. Okay, fine. Thank you so much, guys. We'll meet again tomorrow.
Sir.
Yeah.
I have a doubt in price rearrangement. Like I didn't
Fries
understand
rearrangement. Okay, Fries rearrangement. Okay, we'll see that. Okay, so for Fries rearrangement, right, you need to have an aryl ether. Okay, aryl ether. Okay, so say I have O CH2 CH double bond CH2, or I'll write it like this. Okay, right, that's what I have. Okay, now what I'm going to do is okay, so now say this attacks here, and this bond goes, no, the same mistake I did last time also, right? Wait. Okay, let me start from here. Say now, or if I write the bonds little, okay, now say this will attack here, the bond will break, the single bond is broken, this CO bond is broken completely, right? Now this will attack here, and this bond will go here. That's it. Okay. So if you write the product, right, you have one double bond O, and this carbon is attached to one CH2, and that is having CH with a double bond CH2. Right? Okay. And this stays. Okay. Now what I see is, and this is the keto form, right? Now you please understand that there is a hydrogen atom here, alpha hydrogen. This will undergo tautomerization, right, to form an OH with all the double bonds, or if you want to specify it, you can specify it. One bond here, here, and here, and this thing stays. CH2, CH, double bond, CH2. Yes, understood?
Yes, sir.
Okay, so you just start from here if you want to avoid confusion, right? You break the CO bond, you make it double bond O, and make the attack here, and everything will be fine. Right? And at last, you have to remember that it is undergo tautomerization forms. That's it.
Yes, sir. I didn't know where to start.
Yeah, it's better. Even I get the confusion. So it's better to start from here. Break the bond. Okay?
Yes, sir.
Right. Fine. Is there anything else?
No, sir.
Okay, cool. Thank you so much. Meet.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.